Hey everyone, September 4th, 2022, and today we're going to take you along most of the type section of the members, the sedimentary ones, for the Copper Harbor Conglomerate or Copper Harbor Formation. I redefined the whole thing back in 2018. That paper is available. I'll give it to you if you want or are interested in it. And it also appears in the Roadside Mining Geology book of the Upper Peninsula. But here, we're going to stop at the bottom of the formation and work our way up stratigraphically. So we're going to get progressively younger by heading north. We're at the lowest sedimentary unit, up on top of the Portage Lake Volcanics. Once the volcanism all but stopped, and you're going to see some of that, what happened was sediment started to come in. Well, most of it's alluvial fan deposits, fluvial stream deposits that began to fill the Big Continent Rift as that rift failed. They are discernible into members. The falls that you hear behind me, this is Great Conglomerate Falls, the bottom member. This is the type section of it. Here, it's mostly clast-supported conglomerate. The clasts are huge, cobbles to boulder size right here. That pretty much defines this lower member, and it's discontinuous. It's not continuous throughout the Copper Harbor. I tried to do this in a way where you could divide out alluvial fans if you needed to later. So this is the really core stuff at the bottom. It would fill the deep valleys where the volcanic stop, the deepest valleys would have this more coarser stuff. Now, if you look down here, you see that, Steve, there's no conglomerate there. This doesn't even look like a sandstone because there are some sandstone units here. And you look over here, like, that doesn't look like conglomerate. No, it's not. And down there either, behind me. What that stuff is what I've formally named the Potawatomi flows. Traditionally, there's been an informal name for all these last gas volcanics within the Copper Harbor Conglomerate called the Lakeshore Traps. Well, according to the North American Stratigraphic Code, that is not a legitimate name. You need to name it after an actual physical semi-permanent place. Just to say lakeshore isn't applicable, and traps is not a recognized formal lithostratigraphic tag-on. So, Potawatomi flows is, and it is named after a local geographic feature. And these are the first of the last gasps of the lavas. And here along the Black River, which is this here, these are the only volcanics we're going to see. Now, higher up within the Copper Harbor, other places, closer to the Keweenaw and stuff like that, there are other units. But here, this is it volcanic-wise that we're going to visit. So you have conglomerate all right here. And there's your Potawatomi right there. And it continues back there. I forget off the top of my head how thick those volcanics really are. And this way is south. And if you go far enough south, you'll get to the contact with the older underlying Portage Lake volcanics. And you'll see things like white calcite. This stuff fills the voids that would have existed when this was deposited between clasts, since this stuff does lack a supporting sandy matrix. Now, there is sand here, obviously, but that's about as much as you'll see. And this thing, you see my foot's just under 30 centimeters, so that gives you a sense of that boulder. And these clasts are made of the underlying Portage Lake volcanics, basalts, rhyolites, andesites, those types of things. Come back up to the falls here. A little backtrack to actually go that way. They split. You can see that if you look upon close inspection, that the falls are pretty much with dip. It's really hard to get strike and dip on something like this. You've got to look for things like this. This is one of the rare bits of sandstone in this Great Conglomerate Falls member. Now, the Great Conglomerate Falls pretty much looks like this everywhere. It's this reddish gray color. The sand's very red. What little sand it has tends to be pretty good on the level part. There's not too much sedimentary structures. And strikes about this way and dips that way. So dip is basically north. It's not exact, but it's north. And it's, I forget off the top of my head, I correct it on screen if I'm wrong, but I think it's about 20, maybe 30 degrees dip somewhere in there. You can see there is bedding there. There's bedding here. So these are just big alluvial fans deposited in a terrestrial environment. And as this stuff is being deposited, they would get thick relatively quickly because the basin was still subsiding after all that volcanic magma lava had been ejected from deep beneath Earth. So something was pointed out by those lovely people that here, you see this pit, let's even zoom out. This is about to fall. This is about to waste into the creek. And it's separating from the bank. This was not here last time we were here. Is it? You see over it? So it's over the bank. So this isn't sliding this way. This is going this way. There's probably bedrock under it. Hey, we are at Gorge Falls. This is the next member above the Great Conglomerate Falls member. And I actually debated whether or not to divide this out as a member from the Copper Harbor Conglomerate, but I decided to for several reasons. There were sandstone lenses in the underlying Great Falls Conglomerate. However, they were sparse, less than 5% of the volume of the formation, and it was mostly class supported. Here, the class are a little smaller. There isn't a real good reason to divide out another member. It's redder, which isn't another good reason to divide out a member. But the sandstone lenses increase in frequency and size here. And there is some matrix supported conglomerate here. It kind of goes between class supported and matrix supported. The class are still the same stuff from the far underlying Portage Lake volcanics, you know, basalts, rhyolites, andesites, these types of things. So this is a distinct another member. This one is far more extensive and represents most of the hard alluvial fans in the Copper Harbor Formation. Now, as we continue to walk north, we're going to keep getting younger in sections. And the great thing about this outcrop's length here along the Black River, to where you're going to get older, youngest deposits as you walk up section, which here is to the north. Generally, the Copper Harbor Conglomerate does spine upwards. What does that mean? That means we go from boulder, cobble, clast conglomerate to more pebbles with sandstone, and then more sandstone with less conglomerate. However, there is an exception to that, which we are going to see, which kind of got me interested in seeing if I could divide this thing out into members and to test how extensive they were laterally. And they are. Like, so the Great Falls Conglomerate member, tongue, you know, is more lenticular, tongues in and out. This is more dominant. But we're going to go up more and we're going to see less conglomerate. But something happens there. As this was being deposited, our basin was subsiding kind of relatively fast, but it was slowly doing it. This member doesn't have any really measurable volcanics in it. The next one does. Now in the UP book, like I said, this section is here at several different stops, but it's a stylized cross-section. The paper has more detailed graphic representations in it. So we're going to continue north more, and we're going to go to the Sandstone Falls member next. One thing I forgot to mention was that these sandstone and conglomerate members, they don't really have distinct contacts between them unless you have an erosional channel fill or something like that. They're generally gradational with one another, or they intertongue. And the gradation could be a meter, a couple meters, 10 meters. It depends on the depositional environment. You also get strong contacts below and above the lava flows because obviously the depositional environment completely changed really fast. So you get it there too. Now there is a sharp contact between the Gorge Falls member and the next member we're going to, Sandstone Falls member. But it seems local. It doesn't seem to propagate outside this area. Could be channel fill, something like that. But I'll just wait until we get there. We are at Sandstone Falls here. This is the type section of the Sandstone Falls member of the Copper Harbor conglomerate. Now, you heard me say you can't name lithostratigraphic units off generic places like lakeshore traps. So why am I naming this Sandstone Falls? Because someone else named this here. This is a semi-permanent geographic feature that I can use. Now, according to the North American Stratigraphic Code, they encourage you to drop things like Sandstone Falls member. They want you to drop the falls, but you don't have to, and that's problematic here because otherwise it would just be the sandstone member and people would be like, well, you can't name a formation or member after the lithology. So this is the Sandstone Falls member named after Sandstone Falls right here. And what you see here, first of all, is the rock is no longer red. It's purplish gray. You go that way more, it becomes really purple. Other stuff you notice, there's a lot of sandstone here. You look there, you can see the gray sandstone, and you see conglomerate. The conglomerate's more in lenses and maybe 2 meter thick units. Down there is a thicker one, I think it's about 12. But here sandstone dominates. It's like 80% of the formation. Then you get this darker color, and on occasion you will even get more shaly units. This is actually mudstone here, but it's more siltstone. Now you look here, and this, you don't get this in the lower two members. You don't get this in the Great Conglomerate Falls or Gorge Falls member. You can see you have sandstone here, and you can see it's cross-bedded. Then you get some conglomerate, and then your cross-beds go this way. They come up, and you can see a sharp contact, and your cross-beds go this way again. So this is your true bedding about right here. So you get your conglomerate kind of mixed in sometimes with the sandstone too, and cross-beds. Now what this tells us is that our basin was really filling in at this point. After the Mid-Continent Rift died and subsidence continued because all that lava had come up upon the surface, and you start subsiding, the conglomerate's pretty much gone at this point as thick units. You have fluvial stream terrestrial environments here, and you would occasionally get conglomerate in the, river bends and stuff like that, but it was more braided stream here. There are really good ripple marks exposed here. That's another thing that's really good about this member, is you get good primary sedimentary structures like crossbeds, ripple marks, scour marks, things like that you really don't get in the lower two. But on occasion, alluvial fan deposition would happen, like you probably did over there. But dominantly, you were in a fluvial stream environment at this point. So our basin was continuously filling in. Conglomerate was pretty much buried at this point right here. And we are in the upper half of the formation. But we still have one more large-scale laterally continuous unit to go through, but there are other lenses and things that I formalized. They're just not exposed everywhere, like there'll be lenses or tongues or something like that. We will visit one of those little units hopefully here at the very top of the Copper Harbor, that's locally where the river meets the lake. But let's move on to the last member of the Copper Harbor Formation. It's going right here. I think this is a good spot. You can see Lake Superior behind me. All right, I just came from that way, and you can tell this outcrop continues pretty far that way. You can probably see the people down there, I don't know. But we're gonna stop here. I want to talk about this. This is a type section of the Union Bay member of the Copper Harbor Formation. It's the top sedimentary layer of any appreciable extent. It's probably also the largest. There's not a lot of conglomerate here. It's mostly sandstone. And here it's got a lot of hematite in it, making it red. it does look a lot like the Frida Formation, but the Frida is obviously higher in stratigraphic section than this is. This also has some cool things to it too that I discovered when I was doing the paper. Some kind of odd looking things. I'm not sure what they are. They may be biological in origin. When I look at these, and my brain says mud cracks right off the bat, and they may very well be. I don't really know. I may be reading too much into this, but you look at these and they look different than typical mud cracks, especially in sand. You see these high rounded like tubes, if you will, almost. I think those might be rolled up algae mats. And the cracks themselves could still be mud cracks, but maybe it's due to some sort of other biological activity. Maybe those rolled up algae mats had something going on underneath them. I don't know. Like I said, maybe reading too much into it. I'm not a paleontologist, but I do know these do not look like normal, typical mud cracks in a sandstone. And there's other similar structures, not right here, that look even less like mud cracks. And this rock is about 1,087 million years old. Due to the intervening lavas, we can date it. We have. It's a range. It's not exactly all that age, but for all intents and purposes, it's that close. It's not like this stuff was deposited over 100 million years. It's actually probably more like 7 or 8 million years. So, and things like those mud cracks and rolls kind of made me wonder, maybe, just maybe, the assumption that multicellular life was around, 1.09 billion years ago, or 1090, might actually hold some merit. But like I said, I'm not a paleontologist. There's a lot of sedimentary structures here. We have really well-developed ripple marks here, some pretty big ones as well. On different bedding planes. This stuff is highly cross-bedded right here. Now, if you go north more, behind me there, and you follow this outcrop, way up there, you will start to see conglomerate again. The conglomerate does appear usually in thin beds, and it's almost always matrix supported. And that's typical of the Union Bay, along with this red color, sometimes mottled that light bleached color, typical of like the Frida, and even sometimes the even younger Jacobsville group of rocks. So let me see if I can find some other things here and to show you real quick. These are interesting indentations here. Not sure really how they formed. You see they're kind of radial. You see them a little bit. They look footprint-like, but that's not what they are. And this is definitely the top of the bed. It's fractured from here. And so this is also a good example of cast and mold. This is your mold. This was your natural bedding plane. And here's your cast that fell. This was up here and fell down. You can see, you can line up these features with both rocks. So this is the bottom of the bed. This is the top of the bed. This is one of those weird spots where I'm not sure what kind of, these are definitely a primary sedimentary feature. These nubs. This is not called by fracturing. You don't see radial patterns or anything like that. This could be some sort of concretionary like layer within the sand, but lithologically it doesn't look too different than the surrounding stuff. Now there's a lot of gray here, which is hematite, so it could be because of that, or it could be tectonically induced. We know there were still earthquakes in the area at the time. This bedding plane, this entire bedding plane, they're everywhere here. If there's a minor earthquake and the mud balls can form and roll a little bit if it's a long, rumbly, slow-moving earthquake. For lack of a better description, that's not exactly what happens. But if an earthquake occurs and it's kind of long in duration, it can shake this stuff up, this loose mud, roll it up, and move it. And that could be this too. We see larger versions of this at Presque Isle and the Nonsuch, but here it's just small. Okay, just gonna come down here real quick and talk about some stuff. You see this here? This is the Chickadee lens, named after a nearby creek. Yeah, they redid this. This was not, this is not like this when I made that paper. You can tell the concrete's relatively new. I wrote the paper in 2018. This was not here. I made this a lens of the Copper Harbor. We are near the contact with the overlying younger Nonsuch Formation, which is mostly shale. Now, it goes over here and becomes more conglomeratic, and I did have people tell me, well, why did you call it part of the Copper Harbor and not put it as a member of the Nonsuch? Well, there's several reasons. It's definitely at the top of the Copper Harbor. This culvert was not here. But the reason why I did that is because at the type section of the Nonsuch, at Nonsuch, there's very similar looking rock. And that rock, no one says it's part of the Nonsuch. So it's very similar. And is it the exact same thing? No, this is a delta deposit. Stratigraphically equivalent, formed the same way. This here is the Union Bay member. There's where that bridge is. As you can see, there's nice exposures of cliffs, but you can't really access that efficiently. Anyway, that's it. If you have any questions or comments, please leave them below. I hope you learned something.